Hello to all conference participants in Osaka and those watching this presentation online. I'm Magdalena Wróbel-Lachowska from Łódź University of Technology. On behalf of my co-authors Mikołaj, Woźniak, Piotr, Sikorski, Natalia, Bartłomiejczyk, Dominiak, Krzysztof, Grudzień, and Andrzej, Romanowski, I would like to present you the results of the study about enhancing in-game immersion using BCI-controlled mechanics. Every one of us has certainly dreamed of having some superpowers. My dream was telekinesis. In the real world, is this not possible yet? But in a virtual reality, everything is possible. VR experience become more and more immersive and entertaining, mainly thanks to multimodal approach and new control modalities. One of it is brain-computer interface that enable the players to engage in the game not only with their bodies, but also their mind. I would like to present you the result of our study on the influence of employing BCI-driven mechanics on players' in-game immersion. For the purpose of the study, we designed and implemented an escape room theme game prototype that uses plays mental state of focus and relaxation as input to select game mechanics. The game takes place in a fantasy world resembling the medieval area. Through the game, the player's task is to guide the protagonist along his prison break and enable him to escape the death penalty. The player is equipped with supernatural abilities, telekinesis, and so-called alternative vision. The telekinesis ability enables to lift objects without physical interaction with them, and the alternative vision provides with capacity to notice and detect magical phenomena. Both of the skills are controlled either with buttons on the controls-based condition or the player's level of focus or relaxation in EEG condition. To investigate if the user's mental states used as control modality can enhance players' presence and in-game immersion, we used the described game prototype. We conducted a between-subject studies with 28 participants. Two conditions were possible: baseline, a standard VR control setup, and EEG condition. In the second one, focus mental state was used to telekinesis and the relaxation for detecting magical phenomena. Each participant had to go through 4 levels within approximately 30 minutes. We used the signal analysis and calibration protocol by Kong et al. Alpha to theta was used to identify the relaxation state and beta alpha the focus state. To determine the activation threshold appropriate for individual participant, a calibration procedure was necessary. The algorithm was validated with 6 participants in a pilot study. The head-mounted display used for this study was HTC Vive Pro. The device used for data collection was Emotive Insight. The headset was chosen based on its ability to measure signals required for analysis focus and relaxation mental state. Moreover, the device is offered as consumer-grade electronics and is sold at an affordable price, making it a possible comparison to commercially available gaming equipment. These qualities made it a valuable solution regarding system ecology validity. We recruited 28 participants through leaflets at university and snowball sampling. After the experiment, we used popular tools and techniques. The mental workload required to compare the game was measured using the NASA TELIX scale. The level of in-game immersion experienced by the user was measured using Immersive Experience Questionnaire. Moreover, each participant was interviewed about previously measured variables and their overall feelings. To compare whether a significant effect was found, we conduct an independent samples t-test. The Shapiro-Wilks test was used to show deviation from normality. Levin's test revealed that the variation assumption is volatile for the enjoyment subscale, and so we used the Welch-corrected test. We found that there is a significant effect on the total IEQ score, temporal dissociation, transposition, and enjoyment. Hedges shown that BCI had large effect on the score. The immersion scores increased for EEG condition in all 4 dimensions. For nasatalics, we found that there is no significant effect. During interviews, we found out that using the BCI as an input modality encouraged to emphasize with the in-game character and impersonate the protagonist. Moreover, it creates more kinematic experience. We also identify immersion breaking constraints. To sum it up, the logical connection between the actions performed and their representation within the game world was used to create an immersive game experience. Using BCI as input modality encourages the players to emphasize with their characters to build the player engagement. It is a good idea to reflect the in-game narrative. On the other hand, pragmatic and technological issues impaired in-game immersion. To enhance in-game immersion, mind-related mechanics that reflect the in-game narrative can be used. Thank you very much for your attention and feel free to ask questions.